Hi, this video is about solving problems involving the wave equation. James and John were on rafts at a wave pool. They were spaced 0.75 meters apart when some waves started coming their way. They bobbed up and down exactly 2 times per second, and when James was riding the crest of the wave, John was at the trough of the wave, and there were no crests or troughs between them. Determine the wavelength of the wave, frequency, and wave speed. So with this situation, I'm going to start by drawing a picture. So I'm going to draw a transverse wave here to represent the water waves at a wave pool. And I'm going to do it a little bit exaggerated just to make it clear. Hopefully the waves at a wave pool, at your wave pool, are not this big. And then I'm going to look and see where it says they're located on the wave. So it says James was on the crest of the wave. So I'm going to put him here. This will be James. And then it says John was at the trough of the wave. So that could be here or here or here, one of those. But it says there were no crests or troughs between them. So he's not going to be far away because there's nothing between him and James. He's going to be at this location. So these are the two locations of the two people here. It says that they were spaced 0.75 meters apart. So that refers to, this spacing right here. Before the waves came, they were 0.75 meters apart from each other. All right, and then it says they bobbed up and down exactly 2 times per second. We'll get to that part later because what we want to know is the wavelength of the wave. And the wavelength of a wave is the distance from one crest to the next crest, or from one trough to the next trough, or the distance between 2 consecutive repeated points on a wave. What we're given, though, is not the wavelength. We're given the distance between the crest and the trough. But as you might notice, that's really just halfway to the wavelength, because the wavelength would be the full distance from one crest to the next crest. So this wavelength here is just going to be 0.75 meters times 2, because it's 2 of these segments. So the wavelength is going to be 1.5 meters if we multiply those two together. So we've solved the first problem. Now we're looking for the frequency of the wave. The frequency of the wave is actually given to us because it says they go up and down 2 times per second. And if you see something happening, a certain number of cycles or times or repetitions per second, this in itself is the frequency. The frequency is how many vibrations per second or cycles per second. So in this case, it's 2 cycles per second, which we also just call that 2 hertz, Hz. So we have the frequency now, we have the wavelength over here, and knowing those 2 pieces of information will allow us to find the third piece, which is the wave speed, because wave speed is the frequency times the wavelength. So that means all we're going to do here is put in the frequency of 2 hertz times the wavelength of 1.5 meters, and that gives us a wave speed of 3.0 meters per second. So that is our wave speed. So that's the first problem. Let's go on to one more problem like it. This one says that Sarah takes a water hose and shakes it, creating a complete up and down motion every 0.67 seconds. The wavelength of the waves created is 0.88 meters. What is the frequency of the waves and the wave's speed? So I'm going to draw a picture again here. So let me start by drawing Sarah. Okay, then she's holding on to a garden hose here. The garden hose goes up and down like this. Okay, so there's our waves. And it says, we got some more information here. It says the wavelength right off the bat here. We know it is going to be 0.88 meters. So I'm just going to label that on my wave just for clarity. Okay. And then it also tells us we have a complete up and down motion every 0.67 seconds. So let me use a different color. So 0.67 seconds per wave. Now you might see that and think, okay, that's our frequency. But no, it's slightly different because frequency is waves per second or cycles per second. But this is how long it takes for just one wave. It's a different quantity. This is known as the period, which we represent with a capital T. The period is how long it takes for one complete wave. To find the frequency is just the reciprocal of the period. So frequency, in other words, is 1 over the period, 1 over T. So that'll be 1 over 0.67 seconds per wave. And so doing that math, 1 over 0.67 seconds is 1.5 for our frequency. 1.5, that'll be 1.5 waves per second, or 1.5 hertz for our frequency. So done with that. And now we want to find, the second question was, what is our wave speed? So again, wave speed is frequency times wavelength. The frequency we just found to be 1.5 hertz. And the wavelength is 0.88 meters. So we're going to multiply those two together, and that'll give us 1.5 times 0.88. 1.32, we'll round it to have two significant figures, so that's going to be 1.3 meters per second for the wave's speed. So that's all I've got for you in this video. Remember, humility is not thinking less of yourself, it's thinking of yourself less.